Welcome guys. In this video we're gonna do another epsilon delta proof. In this video we're gonna talk about the limit as x approaches 2 of the function x squared minus 3. Notice this is a polynomial, so we might be thinking about factoring when we're doing this kind of the epsilon delta proof. Okay, so the first step, we're gonna, like always, we're gonna find L, the limit. Alright, so to find the limit, we plug it in because this is a continuous function. So we put 2 squared minus 3, and then 2 squared, that's 4, minus 3, that's 1. So L is 1. Okay, now epsilon, let epsilon be greater than 0. Always let epsilon be greater than 0. Sometimes you can put 0, 1. It depends if they give it to you in the problem, but today we're just going to give it epsilon greater than 0. So it could be any epsilon that is greater than 0. Usually epsilon is a small number, so just let it be. We're not gonna choose 1. We're just gonna choose 1 in general. Okay, so the second step we're gonna do the scratch work. We're gonna try to relate delta and epsilon. The way we do it is we start by doing this expression. So we take the function x squared minus 3 minus 1. This has to be less than epsilon. Okay, but first let's expand it out and let's see what we get. So x squared minus 3 minus 3 minus 1, that's minus 4. So that would be x squared minus 4. This is where I told you that we're going to have to factor. So x squared minus 4 can be factored as x plus 2 and then x minus 2. And remember, this has to be less than epsilon. Alright, remember delta has to be is greater than 0 and has to be x minus c. What is c? C is 2, so let's put minus 2 less than epsilon, less than delta. Alright, so we see x minus 2 here, x minus 2 here. Okay, so the problem we know that once we know this, what this something we get rid of this, we can find out our delta. Alright, so x plus 2. Remember, L is 2. So we can choose values of x's. You can choose x's that are between 1 and 3. The maximum is 3. So x has to be less than 3 and values greater than 1 and less than 3. So let's choose the limit. Let's choose an endpoint. So let's see the maximum of this here. Let's choose it to be 3. 3x to be 3. So to find delta, we have to do 3 plus 2 x minus 2 less than epsilon. And then 3 plus 2 is 5. So x minus 2 less than epsilon. Okay, 5 is a positive number, so we can get rid of the absolute value. So all we're left with x minus 2 less than epsilon over 5, because we divide by 5 to leave x minus 2 on the left side. And this is our delta. This is our delta. Because look, remember how we started? X minus 2 is less than the delta. We found a delta. That delta is epsilon over 5. Alright, so to make space, we're gonna delete this. Now the final step to complete this problem is we're gonna write the proof. Okay, so the proof is the final step. Remember, if f of x minus the limit less than epsilon whenever 0 x minus c less than delta. Okay, so our problem, remember, is to find delta. We found delta. So once we found delta, we can choose any epsilon. Okay, so alright, so f of x, what is f of x? Is x squared minus 3. X squared minus 3 minus L. L is 1. is less than epsilon whenever x minus 2, which is our c, is less than delta, which is what? Delta, what we found delta to be? Epsilon over phi. And that ends our problem. Sometimes they might ask you, for example, let's choose epsilon to be 0.01. So all you have to do is, in this, instead of writing this, you're gonna write 0 x minus 2 less than 0.01 over 5. You can compute that number and then get an answer. For example, let's say they give you epsilon to be 0.05. All you have to do, instead of, you write the same thing, but instead you're gonna put 0.05 over 5, and that's it. Thank you very much. Please subscribe to my YouTube videos. I really appreciate it. Thank you very much.